So today we're going to talk about adding and subtracting polynomials, okay? But I don't like subtracting, so of course we're going to change everything to addition. And like I said, this section is a simple section, but people seem to make silly mistakes. I'm going to try my best and give you much tip as possible so that you don't make silly mistakes. Does that make sense? Even though it may take like one or two more steps, you know, if you follow these steps, I think it'll help you do them correctly rather than making silly mistakes. Does that make sense? So that's what I'm going to try to do today. Oh, by the way, what do we call these type of expression like 2x, 5, 7x, 7x squared? Does anybody know what we call these sort of expression? Polynomial, yeah, they're polynomials, but yeah. Monomials is correct, because these expressions, as I just told you, they only have how many terms? One. So these are called monomials, you're right. And we're going to define monomials for you. Does anybody know? Okay, let me actually just tell you what they are. Of course, monomial have one term, right? Monomial have one term. So, and then the way we define monomials is this. Monomial is an expression that is either a numeral. What does numeral mean? What do you think that means? Yeah, number, number. A variable, like x or y, you know. Or it could be, that's the important part here, product of a numeral, meaning number, and one or more variables. As you can see, 2/3 xy, you see that's more than one, that has more than one variable. It's number times a couple of variables. So this is how we define monomial. So that's what we're going to start with, okay? So write that down. Does anybody know? Let me unfreeze this. Does anybody know what we call then expression with two terms? So if expression with one term is called monomial, like mono, one. What about two terms? Yeah. Binomial is correct. So that's the one I want to. So here's an example. It's a expression with two terms are called binomial. 2x plus 4w. That's an example. What about three terms? Anybody want to guess? Yes. Trinomial is correct. Three terms. For example, 3 plus xy plus w. What about full terms? Yeah? We don't have polynomial. we just say polynomial with full terms, okay? We don't have special name for that one. Yeah. So all these, monomial, binomial, trinomial, all these are called, what do we call all of these things? They're expression, but we call them, polynomials is correct. So how do we define polynomial? It's basically sum of monomials, isn't that right? You add a bunch of monomials, you get polynomial. Okay, so it could be binomial, trinomial. They're all polynomial. Okay. Here's a, what do we call this? 2x. It's an expression, but we call, a special name for this would be called the monomial. What do we call this 2? The number in front of x. There's a special name for this one. Claire, do you remember the name of this? Starts with C. Coefficient is correct. I know you. Okay, so it's the I'm going to refer these numbers as so if I say, oh, look at the coefficient, you know what I'm talking about, right? So I'm telling you what it is. Coefficient is a number multiplying the variable. That's it. Very simple. It sounds really hard, but it's not really. Coefficient. Just a number multiplying the variable. Okay, write that down. So, how many people have heard of similar terms or like more likely like terms? How many people have like terms? Raise your hand. You've heard of like terms before? Good. And so, like terms, how would you explain to someone that are a bit confused or have not heard of what like terms are? How would you describe them? What like terms are? If somebody asks you what are like terms, or if your younger brother or sister, I don't know what like terms are, what would you tell them? How would you describe like terms? Yes?
Like something that you can add, like the same. I'm gonna say it.
And there's a reason why I explained what a coefficient is right before. So knowing what you might want to use the coefficient in there. It may make it a little bit simpler to explain what like terms are. I know that a lot of you, who could give me an example of like terms? I know that a lot of you could do that first. Yeah. 2x and 3x, sure, they're like terms. Right? What about x and x? Are they like terms? Yeah. What about 3 and 5? Are they like terms? What about x squared and 5x squared? Yeah. How would you write that as in? How would you describe those things in words? That's what. Yeah. Do you want to try? Same variable or? What do you mean number? Oh, okay. Good. So like 5 and 5 or 5 and 6, they're numbers. Oh, but when you say same variable, there's a problem. Who could come up with an account example? Or who could? Because I could say this: x and x squared. Don't they have same variables? X. Are they like terms? X and x. No. So you gotta say something more than just same numbers or same variables. Anybody wanna try? Yes, sir.
Like terms that have something in common.
Two terms that have something in common. How about this? 2x and 2y. They have 2 in common. Are they like terms? No. So you don't want to say that. William.
Terms with the same exponent.
Terms with same exponent. What if I give you x squared and y squared? So I know you guys. Actually, I'm just kind of playing, devil's advocate here. But do you see? You have to be careful if you're gonna, define what like terms are. Anybody want to try? Like I said, using that word coefficient might help. Yeah. What do you think? Oh, okay. Sorry. No one wants to try. No? You want me to just tell you what I wrote down, or what the book gives you? Okay. Here's what the book tells. Let's see if this makes sense to us. First of all, these are two monomials. I like how you said terms. Okay, but really we're comparing two monomials. Isn't that right? So maybe it was too obvious to a lot of you, but if you have like terms, these are monomials we're comparing, right? It's a monomial to another monomial. That what? That are exactly alike or are same. And if I stopped here, it'd be wrong, right? Except what? Except for their coefficient. Chairman is correct. One person with a hand up. Okay. Except for their coefficient. Does that make sense? You know what I'm talking about here? Because then this kind of covers all the cases we just talked about, right? They have to look exactly the same except for their coefficient. Well, does that mean that they have to have a different coefficient? No, I mean, it doesn't matter really. What you're saying is the coefficient could be same or different, doesn't matter, right? What matters is everything other than the coefficient must look exactly like. Does that make sense?
Yeah.
So for example, here, 3x and 3x, of course. Those are like terms. 3xyz, 3yxz. Well, wait a minute, they don't look alike. This one says xyz, this is yxz. But we know that yxz could be written as xyz using community property of multiplication. Very good. What about 7y and 4y? Are they like terms? Yeah, they look exactly alike except for their coefficient. I mean, and they could have the same coefficient, it doesn't matter. And then, like here, 3x squared y cubed z and negative 7x squared y squared z, right? They look exactly alike except for their coefficient, isn't that right? Okay. So this is how the book describes it, and it makes sense to us, doesn't it? So as you can see, the book does it carefully, because if you're not so careful, the definition might mean something else, you see? So it's two monomials that are exactly alike or same except for their coefficient. Okay. It doesn't mean they have to have the different coefficient every time. They could have the same coefficient or different, doesn't matter. Right? Any question? So before I want to get to where I want to go with these, let me give you some facts that you need to know. Something like this. A polynomial is simplified or in simplest form when? Does anybody know what comes after? How do we know whether or not we have the polynomial in simplest form or is simplified? Because that's where we're trying to get to. Yes, Victor?
When there are no like terms?
Yes, exactly right. When no two terms are similar, meaning there's no like terms anymore. Does that make sense? Yeah, you wouldn't leave it as 2x plus 5x, right? You would write that as, of course, 7x, right? Does that make sense? So we need to know that fact. Another fact that you should be aware of is, oops. Uh-oh, showing you all the answer. So terms are separated by, that's another fact that you should know. Which symbol separates terms? Which operation, I should say? Chris? Addition symbol is correct. Did you guys know that? So terms are separated by addition symbol. But what about this? 2x minus 5. Don't we have two terms there? 2x minus 5? Doesn't the subtraction separate the terms also? Yes?
You use the definition of
Subtraction.
property to make it.
That's exactly
x
right.
plus negative.
Yeah, we need to write it as 2x plus negative 5. Because if I asked you, for example, if you just left it as 2x minus 5 and I said, can you list the two terms of 2x minus 5? Can you write 2x and 5?
No.
No, you'll be wrong if you write 2x and 5. What should you write? Is it really? Yeah. 2x and negative 5 because what?
Adding.
Yes. What symbol separates the term? Addition. Does that make sense? So if you're in a hurry or something, you might just write 2x and 5. That would not be correct. Those are not the two terms. It's 2x and negative 5 are the terms. And as you can see, if I use the addition symbol there, it's really easy to see what the terms are, right? Whereas if I write it as 2x minus 5, some people might write 5 as your term, right? Which is not true. Does that make sense? So you have to know that the terms are separated by addition symbol. Is that okay? All right. Good. Then let's simplify some of these expressions. First example I want to give you is this. And as you write this down, don't do this yet. We'll do this together because I know that some of you could do this in your head. But like I said before, I want to give you some tips and ways to not make silly mistakes. So go ahead and write this down. And let's do this one together, okay? So I know that this example may seem really easy for some of you because you could probably do it in your head or something. But like I said, I want to show you the correct way to do this so that you don't make silly mistakes, okay? And yes, it does involve extra steps, but it's not that bad, okay? First of all, what do you think I'm going to do? Because I don't like subtraction, I'm going to use the definition of subtraction to rewrite this as, yeah. That's correct. Make everything to addition, right? Adding the opposite, right? So I got negative 3x squared plus 5x plus negative 2x plus x squared plus negative 4. Raymond, do you see any like terms in this expression? Oh, you're still writing that? Okay. I'll wait. Yeah, can you tell me some like terms here? Remember, like terms are terms that look exactly like except for their coefficients, right? Sure, 5x and negative 2x is one of them, one pair. Are there any others, Austin?
Negative 3x squared and x squared.
That's correct. And I underline them using these. I put two lines underneath the other two to indicate that these are the like terms. So then I know that a lot of you could do this in your head, but I'm going to use commutative property of addition and associative property of addition to rewrite this as this. Okay. Why do I do that? Because I know that these are my like terms. And that's why I like addition, because you could change the order in which they're written and you could associate them differently. So I know that may be an extra step for you, but guys, I'm telling you, it's going to help you out later. You don't want to make silly mistakes. Then, notice I even put down the invisible 1 in front of x squared. Isn't that right? Because the coefficient of the x squared, even though you don't see it right here, there's really 1 there. Isn't that right? So who could tell me what this becomes? Negative 3x squared plus negative x squared? Ryan? Negative 2x squared. And I'm not going to write negative 2x squared right away. Do you know what I'm going to write next? Why does that become negative 2x squared? What property am I using that we studied? Yes? I am going to use distributive property is correct.